Next one is some more converge diverge. So for this first one, this is a p-series. So this is going to be an n times an n squared, which is n to the third, times another n, which would be an n to the fourth, over an n squared. So that's going to leave you with an n squared on the top, which is like 1 over n to the negative 2. And so this one is going to diverge. And that's because the p is less than 1. This next one is another p-series. And for this one, it's a lot like 1 over n to the 3 halves. And for this one, the p is greater than 1, so it's going to converge. Here's another p-series, and since this is n to the third over n to the third, that's like 1 over n to the 0. And since 0 is less than 1, this one's going to diverge. This is an alternating series, so we're going to find the limit as it approaches infinity. So it's going to be an infinity squared over an infinity to the fifth, which is going to be the limit is 0. So now, to test, we need to see if it's getting smaller or bigger to see if it's going to converge or diverge. And so we're going to test 1. So if we test 1, it'll be 1 squared over 1 to the fifth plus 1. So it's going to be 1 half. And then the next one, we're going to plug in 2. So if we plug in 2 to that, you're going to get 2 squared, which will be 4 on the top, over 2 to the fifth is 32, plus 1 is 33. And since this is getting smaller, and we're only looking at the absolute value ones because we know that it's going to alternate, we see that it's getting smaller, so we know that it's going to converge. And this final one is a geometric. And this geometric here, this is less than 1. And since that's less than 1, we know it's going to converge.